All right, so yesterday we took some notes in our notebook and did some example problems. In this video, you're going to do some example problems with me, and then you're going to have to do some on your own. So I am on page 172, looking at Got It A and B for right now. So Got It A, we have to determine whether it has a constant rate of change or not. So if I look at my table, how do you get from 5 to 10? You add 5. How do you get from 10 to 15? You add 5. And from 15 to 20, you add 5. Okay, so essentially these are your x's and these are your y's. How do you get from 5 to 90? Subtract 5. 90 to 86, subtract 4. 86 to 82, subtract 4. Okay, so my x's were the same, but my y's changed differently. Therefore, there is no constant rates of change. Okay, if there's no constant rate of change, you cannot determine a constant rate of change, so you would be done with that one. Okay, looking at B, we're given a graph, so we are going to write our points as ordered pairs. So we're going to use a T-chart to do that. So if you look at your first point, you go right 8, so that would be your x, and you go up to 80, so that would be your y. So this point is 8, 80. The next one, I go right 16, and then I go up to 60. So this point right here would be 1660. The next point, you go right to 24, and you go up to 40. Therefore, this coordinate point is 24, 40. Now I can look at my rate of change. From 8 to 16, you would add 8, 16 to 24, add 8. From 80 to 60, you subtract 20. From 60 to 40, you subtract 20. Therefore, my x's and my y's change the same, and I have a constant rate of change. And that constant rate of change, if you remember, is always your change in y over your change in x. So my y's decrease by 20, so minus 20, over my x's increase, so plus 8. Now, since that is a fraction, I can reduce it. I can divide both negative 20 and 8 by 2. I would get negative 10 over 4, and I could reduce it again by 2. So negative 10 divided by 2 is negative 5, and 4 divided by 2 is 2. So therefore, my constant rate of change is negative 5 over 2. If we wanted to interpret that constant rate of change, we would look at our x and y table. So my y's, since it's your change in y, is time over number of volunteers. Therefore, I decrease 5 minutes per 2 volunteers. This will be important moving forward, that you are able to label your y and x axis. Since my y's went on top, my y label goes on top. Since my x's are on bottom, my x label goes on bottom. All right, we're going to move over to the next page. We're actually going to skip to page 174 and do Got It C together. So Got It C, we're going to use the table to determine if there is a proportional linear relationship between the mass of an object in kilometers and the weight of an object in pounds. Okay? So first of all, we have to figure out if it's linear or not. So I'm again going to look at my x compared to my y's. So let's say that my x is weight and my y is mass. To get to 20 to 40, you add 20. 40 to 60, add 20. 60 to 80, add 20. So my x's changed the same, so now I gotta see if my y's changed the same. From 9 to 18, I add 9. 18 to 27, add 9. 27 to 36, add 9. Okay, so I do know that it is linear because I do have a constant rate of change, and your constant rate of change, again, is your change in y over your change in x. So my change in y is 9 over my change in x is 20. That can't be reduced, so this would be my constant rate of change. Now I also have to determine if it is proportional or not. To determine if it is proportional or not, I have to put my y1 over my x1, put my y2 over my x2, y3 over x3, and determine if they are the same. Okay? So what I mean by that is my y, this will be my y1, and this would be its x1. This would be my y2, this would be my x2. y3, x3, y4, x4. Okay? So y1 is 9 over 20. x2 is 18 over 40. y3 is 27 over 60. And the last one would be 36 over 80. So I have to see if I simplify all of those fractions, will I get the same, will it be proportional? So if I divide 18 by 2 and 40 by 2, I do in fact get 9 over 20. If I divide 27 by 3 and 60 by 3, I do in fact get 9 over 20. And if I take 36 divided by 4 and 80 divided by 4, I get 90 over 20. Therefore, since all of these fractions are proportional to one another, or equivalent, I could say that this has a proportional relationship. Okay? If I also graph this on a coordinate plane, you would actually see that your first point would be 0, 0, and it hits the origin and then goes in a straight proportional line. Your next task is to do number 1, 2, and 3 on your own.